Hi there, this is the second example of how to solve a triangle using your trig functions. This is really cool stuff. It's at the very end and it works as an amazing review because it forces you to figure out what you know and what you don't know. All right, what do we got here? So we got a triangle and we have one side. What's a good idea? Yeah, exactly. Let's label hypotenuse and then you go around the corner. So this is the adjacent and this is the opposite side. All right. So we got our angles. We got 90 there. We got 51 there. You know what? We can calculate angle B pretty easily. From the previous video, you should remember, or maybe you just know, the sum of the angles in a triangle is always 180 degrees. So if I have 180 degrees to start with, and I take away the 90, which is the square corner, and then I take away the 51 that was given, I want to say 39, but I'm not sure. 180 minus 90 minus 51. Ooh, I don't know if that's what I said or not. But anyway, 39 degrees. Sweet. So I can fill in my angles right now. So angle A is 51 degrees. Angle B, I really got to turn my phone off, is we just calculated. So that's 39 degrees. And angle C is 90 degrees. Let's double check. That's A. B was the one we calculated, and C. All right, cool. I'm going to worry about the A, B, and C afterwards because I've got this labeled all nicely for me and I'm ready to go. So let's see. We have the opposite. So let's find the hypotenuse. So the formula that involves opposite and hypotenuse is sine. So sine, and I'm going to use A. I could use theta, either one is fine, but you know what, I like this. Sine theta is opposite over hypotenuse, because that's the formula, that's the one I've memorized since, never mind, it was a long time ago, since I was a kid. So now I'm just going to change it, and I'm going to have sine A is equal to opposite over hypotenuse. I guess that was kind of silly. I could have used the A in the first place. Whatever works for you. Because right now, where that A is, I know that's 51. Not a bad idea to put the degree there, because whatever follows sine, cosine, or tangent has got to be a degree sign. Okay, you can't use this for opposite and hypotenuse because a degree is not a sign. That's like saying, hey, how old are you? 42 kilograms. That makes no sense. Just like saying, how big is the angle? Or how long is the side? And it's like 51 degrees. No, can't do that. So it's got to go there. Opposite is the one I know, 9 over my hypotenuse. All right, let's get rid of that sine 51. So sine 51 on my calculator. 0.123. If you have a sine and you actually have the angle, then you just have to hit the sine button in the angle. It's when you don't have an angle, if you have an A sitting there, that's when you have to use the inverse. Not so much on this question, probably on the next one. All right, now we're going to cross multiply. So 1 times 9 is equal to 0.7771 hypotenuse. So it went this way, and then it went this way. And if you have those flipped left, right, good for you. It doesn't make any difference. So 1 times 9 is 9 is equal to 0. Hypotenuse. Right, the only point, the whole point, I should say, of cross multiplying is to get rid of that fraction. Okay, please don't start trying to solve it all in one step. Don't, just don't. Write it out, multiply it through. Now we're going to divide by this side by 0. 7771. Oh, not hypotenuse, just that, because this is what we're trying to solve for. And the golden rule of equation said, whatever we do one side, we need to do exactly the same to the other. So this is going to cancel out to 1, which leaves me with hypotenuse. And handy dandy calculator, 9 divided by 0.7771. Oh goodness, look at that. There you go. 11.581. And if we look at our, if we look at our question up there, it's rounded to the nearest whole number. So I'm going to make that 12 inches. This is one I used to do in university all the time. If I wasn't sure how many to round, I would just write extra, and then I would take one more step and round it to what I think was appropriate. So then if it was rounded to something else, then it was kind of like, well, it's not really wrong. She just didn't know how to round, and that's not a major error, as opposed to maybe if I just put 12, it was like too far out, and they're like, oh, I don't know where that came from. It's craziness. All right, so we found the hypotenuse. Now we need to find the adjacent side. As I said in the previous video, you could use Pythagorean's theorem to solve this, but you know what? I don't want to, because down here, I rounded a fair amount. That's like half an inch or almost half an inch. So that means if I use 12 inches in this part, my answer is going to be even more wrong. Not wrong, but more of a compounding error. By going back and using the original information that was given in the question, I avoid that. So now I'm going to use the fact that I have my opposite and I want to find my adjacent. And you should recognize anytime you have the two sides, you need to use tangent. I'm being very correct there. If you wrote tan theta is opposite over adjacent and then just plug the numbers in, that's okay. So tan, and my angle that I know it's 51. Oh, by the way, guys, I would never use in this question angle B, because that's one I calculated, and it's the same thing. I'm paranoid. If I screw up this calculation and then I use, say I got 37 instead of 39, and then I use it in the question, then I am compounding my mistake. So always go back, if you can, use the original given information, because you know for sure that's correct. There's my little rant for today. Is opposite, which I know is 9, over adjacent, which I don't know. And just hold on. I'm going to pause the video.